Thanks, Marion, and thanks for the opportunity to talk to people tonight for me, for many of you in the morning, I imagine. So Marion, when she first introduced me, was indicating that we were working for a group called Eliminate Dengue, which was correct, we were. But in the course of the last couple of years, when we've realized that the intervention that we are working on is broader than dengue, that it actually impacts a range of viruses transmitted by Aedes mosquitoes, or Aedes aegypti in particular, that we've changed our name to the World Mosquito Program. And if anything that I'm going to speak about is of interest to people, you can find out more about the work we're doing from the website that's listed on this slide. So what we've been working on is a new intervention to limit the transmission of Aedes aegypti transmitted viruses. And it involves an intracellular bacterium that's called wolbachia. It's very widespread in insects. It only seems to infect insects and some related arthropods. And it's estimated that somewhere between 50 to 60% of all insect species have chronic infections. And these infections with Wolbachia are transmitted maternally through the insect eggs. What's really quite interesting in discoveries that have been made since about 2008 is that when Wolbachia is in insects, not only mosquitoes but other insects, it limits the ability of different types of RNA viruses to be able to grow within the insect. And in the case of Aedes aegypti, when we artificially introduce Wolbachia into the mosquito, it can be inherited and passed down from generation to generation. And we see that it greatly reduces the ability of mosquitoes to transmit viruses like dengue, Zika, chikungunya, and yellow fever. What's particularly important, I think, from a public health perspective about this intervention is that once it's applied, the Wolbachia maintains itself in the insect population across generations. And so it only has to be applied once. And that's what we're seeing in our field data, that one application, if you like, from probably 2 to 6 months to do the deployment. But once it's deployed, it sustains itself in the mosquito population. And our earliest data is from 2011 in Northern Australia, and in those mosquitoes populations still to this day, 9 years later, we're still getting all of the mosquitoes to carry the infection. And the result of this is that the intervention is very cost effective. And some pieces of work from health economists that have been done recently suggest that in many urban settings, the Wolbachia method that we're working on should actually be cost-saving for governments when you consider all of the costs around diseases like dengue. So what we're doing is really quite simple. We have mosquitoes that we've introduced Wolbachia into. We grow them in the laboratory, and then we release them into the wild, where they will mate with the wild mosquito population. And then over time, we'll see that the frequency of mosquitoes that carry Wolbachia will increase until virtually all mosquitoes in the population have Wolbachia. And there's a number of reasons why this happens this way, something called cytoplasmic incompatibility that Wolbachia induces in mosquitoes. But in the constraints of the time for this presentation, I won't go into the detail of that. But I think it's a key feature of the intervention. So what we're doing is going to locations where we're testing this method and releasing mosquitoes that have Wolbachia. And we do that in different ways. So here you can see some work in Mexico where we have these cups, if you like, and here mosquito eggs with diet in a gelatin capsule goes into the container. You add water and then leave it hanging from a tree in this case, and the mosquitoes will release themselves over a period of a couple of weeks. In this picture here, you can see some workers that work in our project in Indonesia, and here they're actually carrying reusable buckets that mosquito eggs are going into. Here's some work in Fiji where we've been using drones to be able to do adult releases effectively, and here in Brazil where we have releases being done from motor vehicles. So a number of different ways in which these mosquitoes get released, but the key property we're wanting to see is that the Wolbachia invades the mosquito population, that we're not killing the mosquitoes, we're just introducing Wolbachia to try and limit the transmission of the virus. Currently, we have projects underway in these different countries around the world, so working in 12 countries. We've been a little bit disrupted with COVID. Actually, we've been very disrupted with COVID, and all of our projects have been put on pause. We're just seeing some of those projects restarting at the moment. And what I wanted to do today or this evening was just to show you some slides showing some of the data we're getting from these different projects, which I think is very encouraging with regards to impact on disease. So firstly, where we did our first releases was in Northern Australia. And what we're looking at here are two graphs. The top graph is showing dengue cases historically in Northern Australia and across the cities of Cairns and Townsville. And point 0 is the zeroing time when the wolbachia was deployed, and then these data go back 10 years prior, and then a number of years forward from the point where the releases were made. And on the top graph, we have local transmission, and on the bottom graph, we have imported transmission. So these are cases that are coming in from people that may have travelled to Indonesia or surrounding areas and brought back dengue virus in their bodies. And what you're seeing here is quite a dramatic impact on local transmission of dengue in Australia. So this interrupted time series is suggesting quite a significant reduction in dengue, measured to be around 96%. Yeah, here is the number here. Some other work we're doing is in the city of Jakarta in Indonesia. Here you can see the island of Java in Indonesia, and the city is centrally located. It's a very dense city, around 400,000 people. We've been doing 2 studies within this city. So in the center here, in yellow, we have a cluster randomized controlled trial, which has just stopped and is in the process of closing out and being prepared for analysis. And prior to this, we also ran a quasi-experimental study. So this was just a single comparison of one area of the city compared to a control area on the other side. And in this is a controlled interrupted time series analysis of dengue case notifications. So using the passive surveillance system. So both of these studies have been running side by side. And the quasi study we have the data for now, and I can show you. But first, I think good to look at the comparison of dengue transmission in those 2 areas, the treatment area and the control area, historically from 2006. And you can see that it's quite concordant between those 2 areas. And 2017, we introduced wolbachia into the mosquitoes in that area, the intervention area. That the blue here is showing you the frequency of wolbachia in the mosquito population over the subsequent years. And if you look at what's going on with the dengue, suddenly you see that it's becoming not concordant any longer, and that we're seeing transmission in control areas, but not in not nearly to the same extent in the intervention area. And so we're measuring through this interrupted time series in this city, which is has a very intense endemic transmission of around a 76% reduction. And we're very anticipating in coming weeks to be able to see the results from the large randomized controlled trial that's been running in the same city. So again, as in Australia, we're seeing a very significant reduction in transmission of dengue in this setting. If I move across to Vietnam, we've had a study running around the city of Nha Trang in central Vietnam, and some work we've been doing in preparation before moving into a large deployment into the city was a smaller study in a village called Vinh Long to the north. Only treated around 12,000 people in a small area. And again, same sort of data, comparing that area to the city of Nha Trang, which is close by. A little less concordance than what we see in Indonesia, but what we did notice in 2019, very large outbreak in the adjacent area in the city of Nha Trang, but really similar types of dengue levels in this area. And so when we compare those two, it's showing around an 86% reduction in dengue incidence in this case. So all of these studies that I'm showing you so far, none of them is really the gold standard. They're all second level, if you like, quality of evidence, but they're all pointing in the same direction. And we're very eagerly awaiting the randomized controlled trial as very high quality evidence. But certainly these studies that we're seeing observational data from all point in the same direction, which makes us quite optimistic. Here, work we've been doing in the twin city of Rio de Janeiro and Niterói in Brazil, where we've had, dengue circulating, obviously, but also in the last year or so, there's been a fair bit of transmission of chikungunya as well. And I can show you a similar type of data. Here's for dengue in one zone of Niterói that we're working. Again, prior to our release, you can see concordance in the data. We release wolbachia. Frequencies are intermediate at this stage, and this was done. But again, we see this quite a significant difference occurring. And so we can measure this one to be around 73% reduction. And here with chikungunya, we don't have the prior data as the virus is only recently introduced into the city, but seeing similar type of data that we're seeing what looks like a similar type of reduction for chikungunya as well. So we've been accumulating this evidence from different parts of the world, and as I said, we have this large trial about to read out, and I have to say I think the data is incredibly encouraging. For dengue, there's very few things that are working. Fogging insecticides, we know it doesn't work. Source reduction doesn't work, and we know it doesn't work because the case counts keep going up and up and up. And it's proving to be incredibly difficult disease to control. And so we're very encouraged by what we're seeing and hoping that we will have something here that we think can make quite a difference. So we're measuring significant reductions in dengue in all sites that we're working. We've not seen any sites where we've seen no reduction or an increase. As I said, the evidence, preliminary evidence at the moment is accumulating in other sites in Asia and Latin America, telling a similar story. Currently, our studies in different cities of the world have reached around 5 million people to date. And we're hoping if the data continues to look good and we're seeing no negative signals in anything that we're doing, that number could be greatly increased in the coming years. Our goal would be, at least pre-COVID, was that we ambitiously hoped that we might be able to reach 100 million people in the next 5 years. But given what's happening with COVID, we think that that's probably overly ambitious at the moment, but we'll wait and see, but hopefully we'll be able to get it to many, many people. We're not seeing any safety concerns or adverse events in anything we're doing. And as I said, the cluster randomized trials just completed in Jakarta, Indonesia, and hopefully that data will be released soon to the community to be able to see. And so in a short presentation, that's what I wanted to share. And if there are any questions that people might have, I'm happy to take them, or I would guide people to our website if they'd like to learn more about the work that we're doing.